Hello, everyone, and thank you for joining us. This is our third call from the Azure Networking Deep Dive series. I am Sally Mahamde, and I am a networking pre-sales engineer. And today I am with Christoph and Richard, who are our networking partner sales executive, Federico Guerrini, who is our networking and security lead, and Victor Arzate, who is a networking program manager and who is going to join us in this call and moderate the IM window. Please feel free to share your comments, to share your feedbacks while we're doing the presentation. At the end of this presentation, we will I will check the questions and I will see if there are some of them are still unanswered, and I will take them online during some Q&A time. So, the agenda for today. I will do a very quick introduction of this series and the team for those of you who are new or who have not watched our previous calls. I will then hand it over to Richard, who will give us an overview of the networking system integrators ecosystem. And then I will take over to walk you through how Inter-Vnet connectivity works. And then we will take some time to do some Q&A. So for those of you who don't know us, we are a regional team. We cover Europe, Middle East, and Africa, and we are networking sales specialists. Our goal is to help you better understand the way networking works in Azure, and also to help you in planning and designing the connectivity to the Microsoft Cloud. We do follow a readiness plan. We started with 2 webinars which really covered the basics of Azure virtual networking and how you can build your own virtual network. And the sessions will get more complex. I guess the last session will be the most complex one, but the idea here is to walk you from the simplest scenarios to the most complex one. We do this once per month. We do this over Skype. We started in October. And this is our third call, and our last call will be in June. I'm very, very happy to see that we have a lot of participants who are outside of Europe, and I hope that the time is convenient. I know sometimes it is not. So if this is not a friendly date and time for you, please just watch the recordings online, and I will share the link with you later. In terms of the format, sometimes we will have our PSE, so our partner sales exec, that will give us a business overview, and we will always have a technical overview with a focus on a specific subject. In terms of the audience, everybody's welcome. Microsoft field, customers, partners, as long as the most important thing is that you are interested in Azure networking and that you do need our support on understanding how it works. I just wanted to remind you of our agenda for this calendar year. We did start in October by a session on Azure Virtual Networks, the basics, how it works, and what are the key components to know. Then we had a session in November that was around securing virtual networks. And today's session is going to be about connecting virtual networks. If you are interested in getting an invite, or if I have missed inviting one of your colleagues or one of your partners, please feel free to email me. So my alias is sallym@microsoft.com. You do not need to fill the subject of the email, but please just put Azure Networking Deep Dive, and I will know how to manage the email. And I will basically add you to the list I use every time I send an invite. So if you would like to attend the future sessions that will be taking on again in January, just please email me. The recordings. I do upload the recordings one day after each session, and they are all available on Channel 9. You can either look for the series, Azure Networking Deep Dive, EMEA-TZ, or you can go through this link, and you will have all of the recordings, and you also have the themes that we have covered, and you can actually directly click on a theme to watch the part of the recording that covers it. And now I will hand it over to Richard. Richard, can you hear me?
Yeah, good afternoon, everybody. Thanks, Sally, for the intro. As Sally mentioned, I am the partner sales executive for Express Route and Networking across Europe, Middle East, and Africa. So if you've got any questions with regards to partners or commercials around ExpressRoute, please feel free to reach out to me, and I'll be more than happy to have a call with you. So as Sally mentioned, we always try and listen to our customers, and one of the main questions we were getting asked quite a lot over the last sort of 6 to 8 months was really around who can I work with as a system integrator to help me set up ExpressRoute or networking in general. We obviously understand that, you know, a lot of customers work with their telco partners, but then maybe with the telco partner won't do the BGP for them. And, you know, this is quite a complicated situation. And customers said, you know, who are the best SIs to work with? So what we did is about 6 months ago, we started what we call our SI ExpressRoute program, where we've started to train up a number of our system integrators. And there's just a list of a couple on the right-hand side there. Across the region of EMEA, we're looking to get 2 per region that you guys can use, and in the larger markets up to 4, who can really support you if you are looking for that additional help when implementing ExpressRoute. I've listed a couple of the things and the areas that the guys can support you on. So obviously advising on your telco partner, helping you with setting up the BGP, you know, supporting you on your overall network design. I know a lot of customers today are looking at developing a hybrid infrastructure, and a lot of these SIs specifically focus on hybrid and helping customers build their hybrid solutions. And really, you know, and we're seeing a lot of customers looking for that kind of end-to-end support, helping manage the carrier relationship, maybe the Microsoft relationship, and also some sort of hosting relationship as well. So again, this is some of the services that the system integrators offer. I guess, you know, we like to sum it up by, you know, we see these guys as being your, you know, the cloud migration agents, really helping you take that step to cloud, or, you know, evolve your use of cloud. And as networking becomes more complicated, we hope that these sort of guys will be able to support you. So if you do have any further questions or queries around, you know, who you could work with in terms of an SI partner, do drop our alias an email, and we'd be more than happy to pick that up and help advise you accordingly. So Sally, I think that was all from me, and I'll hand over back to you for the technical deep dive.
Thank you very much, Richard. Thank you. Let me take over as presenter. Okay, great. Does everybody see the slide that says connecting virtual networks?
Yes,
okay,
I do, Sally.
Okay, thanks. Okay, so today I will walk you through the options of connecting virtual networks. There are 2. IPsec tunnels, what we also call VNet to VNet connectivity, and VNet peering. IPsec tunnels will offer cross-region connectivity, but they will require a gateway, and that limits the throughput. VNet peering is intra-region only, but it does not require a gateway device, and therefore it offers higher throughput. So I will go through the details of how every model works, and then share with you some insights on how you can configure it. And if you have any questions, as I said, just share them through the IM window, and Federico and Victor will pick them up. So let's start with VNet to VNet connections. VNets can be connected with each other via IPsec tunnels. What this means technically is that this will reflect in the route table of every VNet. We will be adding to every VNet the address space of the other VNet, so that the traffic will directly follow an Azure rule and will always use the site-to-site connectivity in order to make traffic flow between 2 VNets. So if we take this specific example, in this specific figure, I have VNet 3 and I have VNet 4. So when I create the site-to-site connectivity, going from VNet 3 to VNet 4, and also from VNet 4 to VNet 3, I am allowing every system root table, so for VNet 3 and for VNet 4, to integrate a rule that says every time I see a destination IP that is within the address space of the other VNet, I know that I will have to take this path, which is the IPsec tunnel path, in order to take the traffic. So again, this is reflected in the two system root tables for VNet 3 and also VNet 4. Now, it is possible to take VNet 3 and connect it with multiple VNets. So connected with VNet 4, connected with VNet 5, connected with other VNets. And again, technically this means that once I created the first connection, I am adding in the system root table of VNet 4 the address space of VNet 3. And I'm saying that every time I'm creating a connection between a virtual machine in VNet 4 and VNet 3, I should take that path. And the same goes also for VNet 3. Now, if I add VNet 5, I am basically saying that also in the system root table of VNet 5, I am adding those rules that will allow me to always understand when the destination IP is within the address space of VNet 5 to take that IPsec tunnel. Now, as you can see, there is no transit routing. So VNet 4 knows how to talk to VNet 3, and VNet 3 knows how to talk to VNet 5. But VNet 4 and VNet 5 do not know how to talk to each other. They do not have any routes in their tables that allow them to send traffic and communicate. And in that sense, if you wanted to achieve any-to-any connectivity, you would need to implement some mechanisms in order to make that possible. First one being a full mesh topology. So basically, you would implement VNet to VNet connectivity between VNet 4 and VNet 5. You would also do VNet to VNet connectivity between VNet 3 and VNet 4, and you would also do VNet to VNet connectivity between VNet 3 and VNet 5. Another option, a more dynamic one, would be leveraging BGP support. So BGP over VPN is something that, a feature that we released this summer, and it can be very interesting in this specific scenario. BGP is a dynamic protocol. When it is implemented in the same use case, I am basically saying that every time traffic is sent to the address space of VNet 5, I want the BGP device will inject that traffic through the VNet to VNet connectivity to VNet 3. And basically by default and dynamically, any traffic that's within the address space of VNet 5 will always take this VNet to VNet connectivity. Now, if I also connect VNet 3 to VNet 4, and I use BGP as well, I am also dynamically injecting in VNet 3 the routes that come from VNet 4. So, I am basically saying here, VNet 3 is injecting through the BGP protocol all of the routes from VNet 4 and also from VNet 5. So VNet 3 can actually talk to VNet 4, can actually talk to VNet 5, but also can take traffic from VNet 4 through VNet 3 to VNet 5. In this specific scenario, VNet 4 does have a route and can send traffic to VNet 5 because VNet 3 accepted to act as a transit network. So this is one of the advantages of using BGP over VPN. In terms of configuration, you will always need, in order to set up a VNet to VNet connectivity, 4 components or 4 elements. The first one being the gateway for VNet 1, the second one being the gateway for VNet 2, and then you will also need connection objects from VNet 1 to VNet 2 and from VNet 2 to VNet 1. It's important to note that every connection object has a direction, so you would need to be bidirectional. For those of you who have not followed our first calls, we did explain how virtual network gateways work, but I would like here to give you just a quick reminder to allow you to better understand how this works. Virtual network gateways are layer 3 devices, and they route traffic to remote networks. They are always attached to an Azure virtual network, and they are provisioned in a subway that's completely reserved for them that we call the gateway subnet. They are highly available by default, and the gateway subnet is always part of the VNet's address space. And each gateway will be associated with a public IP address, which will be automatically given to it by the Azure load balancer. There are two types of gateways. Right now, and in this session, I am only going to talk about VPN. But in our future sessions, we will be covering hybrid connectivity. We will also cover ExpressRoute. So when picking up the type, for this specific scenario, you would pick up the type VPN. But it's also important to note that you can actually make both gateways coexist. You can have VPN and ExpressRoute gateways in the same virtual network. Each of them has different technical specifications, let's say. But right now we will just focus on VPN, and when we do the session on ExpressRoute, we will walk you through the details of how the ExpressRoute gateway works. So, in terms of the steps, when you need to provision the virtual network gateway, you would select the gateway type. So in this specific scenario, for IPsec VPNs, you would pick up VPN. And when you pick up VPN, you will be asked to make a selection of the VPN type. And there are two types, route-based and policy-based. And I will explain just a bit later what is the difference between both. And the last thing you would need to know is to select a gateway SKU. The SKU defines the throughput and the features that are available for your gateway. You can start by a basic gateway, you can require a standard, a high perf, ultra perf. The choice you make on the SKU will affect the features that you will get. So, in terms of the VPN type, for our scenario, we're talking about BGP over VPN, you will require to use the route-based gateway, simply because policy-based does not support BGP, and it only supports one IPsec tunnel, and it does not support point-to-site connectivity. We have a table, so if you go to azure.com, and then you type the virtual network gateway, you do get this table. And in this table, you see the different categories, and you see the performances, and you see what's supported and what's not. In our case, what is really important is to look at the route-based standard VPN gateway or the route-based high-performance VPN gateway. If you look at the first row, you see the throughput. In terms of throughput, in a standard mode, you get 100 megabits per second. When you are in high performance, you get 200 megabits per second. And if you look at the number, so the maximum number of site-to-site connections, you are limited to 10 when you're using standard VPN gateway, and you're limited to 30 when using high-performance VPN gateway. And as you can see, both support a BGP. Now, it's important to note that when I'm mentioning 10 site-to-site connections for route-based standard VPN gateway, or 30 for the high-perf, I am saying basically that those 30 or those 10 are going to share the throughput. They're going to share, if they're 10, they're going to share the 100 megabits. If they're 30, they're going to share the 200 megabits. So there's this throughput limitation, as I mentioned earlier in the call, that is still associated when we use site-to-site or VNet-to-VNet connectivity. So let's get back to the configuration. Here is a sample of a script. I don't want to walk you right now through the details of the script, but I just wanted you to know that in terms of the steps, you have 4 steps. You create the first gateway, you create the second gateway, you create the first connection with a direction, so from gateway 1 to 2, and you choose the connection type, and that is VNet to VNet. And then again, from gateway 2 to gateway 1, you choose the connection type VNet to VNet. And if you notice here, let's say, the connections, both connections will share the same shared key. This means that this is the element that they will use to trust each other and to build this interconnection. So, we have discussed 2 ways of achieving VNet to VNet connectivity. We have discussed the full mesh option, and then we have discussed the BGP and transit routing option. In the first case, you can get efficient routing. Each VNet is directly connected to any other VNet. In the other option, traffic between VNets may cross one or more transit networks. In the first option, you can have many VNet to VNet connections, and you will have to maintain those. In the second option, you can have any-to-any connectivity. It is possible, and it will probably require less VNet to VNet connections. In the first option, you will require the gateway, so the virtual network gateway, and you will be capped. The performance will be capped by the bandwidth, but that still applies in the second option. So if we compare the pros and cons of the two possibilities, we do realize that there are some limitations. And the only way of addressing those limitations is by using VNet peering, which is another feature that we released this summer, and it's been in GA since September, October, and a lot of customers are very interested in it and are asking us questions on how to design it, implement it. So let's see how VNet peering works. If we try to explain what VNet peering is in simple words, it is basically a mechanism, and it allows connectivity between two virtual networks. They have to be in the same region, and the connection always goes through the Microsoft, through the Azure backbone. So in terms of management, you would still need to manage those as separate resources. That does not change. However, what changes is that when virtual machines in those virtual networks need to communicate with each other, they can do this directly by using private IP addresses. So basically, it is as if we were merging the two Azure virtual networks so that virtual machines in those two virtual networks can communicate as if we had just a very big VNet and not two separate VNets, as you can see in the figure here. So there are some key facts and some requirements to be aware of when designing Inter-Vnet connectivity using VNet peering. The first one is that the traffic across VNet peering will be managed in a very similar way to Intra-Vnet traffic. And in terms of performance, we do provide the same performance as Intra-Vnet traffic. So VNet peering does support working across subscriptions when all VNets are in ARM. If VNets are mixed, so some of them are in ARM and some of them are in ASM, you would have to peer those VNets within the same subscription. If you're not familiar with the ARM and ASM, so resource manager model and service manager model, I really encourage you to go through our documentation and understand how this works. Basically, the ARM model is based on resources. Everything you create in Azure is a resource. A virtual machine is a resource. A virtual network interface is a resource. And you manage resources. So you group them by themes and you manage them. You can manage networking resources, that's one group, and you can manage them all together. Whereas before we really worked on a service model and you were managing services and not resources. So I will mention ARM and ASM a lot in this call. If you would like to be more comfortable on this subject, I really encourage you to go on the documentation on azure.com and see both models and how they work. In terms of limitations, you can only So if you work on peerings, you can create 10 peerings per VNet. That is the limitation right now. In terms of the requirements, as I mentioned a bit earlier, you have to have your virtual networks in the same region. And also at least one of the two must be in ARM. And you cannot have any overlapping IP addresses between two VNets that are peered. In terms of benefits, there are three main benefits. The first one is that you would get lower latency and higher bandwidth, and I will explain that just a bit later. The second one is that with VNet peering, you can use resources such as network appliances or VPN gateways as transit points. So you can use a VNet, and then in that specific VNet, you can install a firewall appliance, and then you can make your traffic always transit through that VNet to co-reach other VNets that are peered to it. The third one is, this is a way that gives you the ability to connect virtual networks that are in ARM and ASM and get full connectivity between the resources in those virtual networks that are not from the same model or the same management model. We do get a lot of questions around latency and bandwidth and how this would work. Basically, the network latency for a round trip between two virtual machines that are in two different VNets that are peered would be the same as within two virtual machines that are in the same VNet. And the network throughput is based on the bandwidth that is allowed for the virtual machine, and that is always proportionate to its size. So if we take a large virtual machine, that would be around 1 gigabits per second. The traffic between the virtual machines in paired VNets is routed directly through the Azure backbone. We don't use a gateway, and it never goes to the internet. So because we don't use a gateway, we don't have the limitations that I mentioned a bit earlier around VPN gateways, which are limited even in top performance mode to 200 megabits per second. So one of the key facts around VNet peering is that it is not transitive. This means that in this figure, for example, where I have VNet 1, VNet 2, and VNet 3, VNet 1 and VNet 2 are peered, and they can send and receive traffic from each other. VNet 2 and VNet 3 are peered. They can send and receive traffic to each other. VNet 2 is peered to both VNets. That means that it can send and receive traffic from each of them, but it cannot send the traffic from VNet 1 to VNet 3. It cannot it cannot do that transition between the traffic. Also, VNet peering can work in a hub and spoke mode. So if we take this figure, for example, we have a hub side of shared services. And that hub side is paired with the HR VNet. It is also paired with the marketing VNet, and it is also paired with the engineering VNet. Now, all of these VNets that are paired to this hub site can talk to the hub site and receive traffic from the hub site, but they cannot talk or see each other. You can go for a full or a partial mesh. So to start, you can pair marketing VNet and engineering VNet and get a partial mesh. But you can also pair HR VNet with marketing VNet, and this way the VNets do see each other and can talk to each other. Another feature that is available with virtual network peering is transit routing. So transit routing is the ability that you can give to a virtual network to route the traffic which has not been originated in it and is not destinated to it. And in the same example, in the same figure, this would mean that if virtual machine 1 wanted to talk to virtual machine A wanted to talk to virtual machine B, you can actually use transit routing because you have paired VNet 1 and VNet 2. You have also paired VNet 2 and VNet 3. So basically, traffic would go from VMA and then would go through the virtual appliance, which is in the virtual network 2, and then would transit to virtual network 3. That is what we call transit routing. If you want this to happen, because by default it is not possible, you will need to activate this through the portal. So when you do go to your virtual network page, you will see on the left side a sort of a list. Configurations, diagnostics, etc. And there you see the word peering. When you click on that word, you can add peerings to your virtual network. You would have to fill in some details, as you can see here. So you have to give a name to your peering, and you have to say how your virtual network is deployed. Is it in ARM, so the resource manager model, or is it in ASM, the classic model? You would have to pick up the subscription, pick up the virtual network amongst the list, and then you would have to allow forwarded traffic, as you can see here. And as I said, by default, this is not activated. Another possibility, another feature that you can use is gateway transit. So basically, it is the ability that you can give to a virtual network to route the traffic which has not been originated in it and is not destinated to it in this specific scenario. So again, we do have VNet 1 and we do have VNet 2, and both are paired. And we also have an express route circuit or an IPsec tunnel between VNet 2 and the on-prem environment. What this means is you can actually decide that every time the traffic would need to leave your on-prem environment and reach your Azure environments, you would ask the virtual network gateway to transit that traffic through another VNet that is paired with its VNet and take it to it directly. So the virtual network gateway is not the destination, It is only taking the traffic from the on-prem environment and it is taking it to VM A because VNet 1 and VNet 2 are paired. So, in order for this to work, there is a requirement. Both VNet 1 and VNet 2 must be ARM. So they both must be in the resource manager model. And also, you would need to explicitly enable this in both peers. So, on the first VNet, you would say, you would click tick a box which says allow gateway transit. So basically, use my gateway and let it transit the traffic to other VNets I am paired with. And on the second side, which is VNet 1, you would use remote gateways. So I, in VNet 1, would like to use a gateway that is not within my own virtual network, but I am paired with a virtual network that does have a gateway, and I would like to transit the traffic through that gateway. It is important to mention that if you do this, you cannot have a gateway in VNet 1. So, when you implement this, on one VNet you would use the allow gateway transit, and on the other VNet you would allow the remote gateway transit. And the other VNet, the one that's using the remote gateway, cannot have a gateway. We do receive and get a lot of questions around how peering works with NSGs. So by default, as I mentioned, when you do peer two virtual networks to each other, by default what you get is full connectivity. So full connectivity as if both are part of the same, of a bigger virtual network. If you did not want this, you would have to implement NSGs on specific subnets or on virtual machines. And you would have to specify with rules what you would like to block or deny. So you would basically get by default full connectivity, and if this is not what you want, you would have to implement NSGs. We did go through how it was actually an introduction around NSGs during our first call. So if you are interested in getting more information around that, please watch the first and the second recording. We had specific chapters around how NSGs work. And so when users configure peerings, they can either open or they can close the NSG rules between the virtual networks. In terms of configuration, a virtual network can include it in its peer address spaces. So yeah, the virtual network can include its peer's address space in its virtual network tag. So if we take again the same example, the same figure, we have virtual network 1 and we have virtual network 2, and these are the tags for each network. One thing we could do is we could peer those two virtual networks. Once we have created this peering, on every site, so again, we do this going through the same steps. We go through the virtual network 2, for example. We look for the peering from the list of possibilities around the virtual network. And once we have filled all of the details, we decide that we want to enable the option that says allow virtual network access. And once we have done this, we are basically including for virtual network 2 and its virtual network tag, the address space of virtual network 1. And then we would also do the same task on the side of virtual network 1. So we would enable the feature that says I would like to allow virtual network access. By default, if we do this on both sides, the address space of virtual network 2 is available in the virtual network tag for VNet 1, and it is the same case for VNet 2. There is another flavor of this. You can basically decide that virtual network 2 should not include virtual network 1 address space in its virtual network tag. And if you wanted to do this, so to have this just in one way and not have it bidirectionally, you would go on the peer that you are doing on virtual network 2 side, and you would click on disable for the specific feature. And you would leave it as enabled for the feature for VNet 1. So there are different flavors of doing this. It really depends on what you are trying to achieve and what is the specific use case. If you do activate both on both sides, you're making this bidirectional, and this is included in both virtual network tags. And if you decide to only keep it on one side and deny it on the other, this basically means that when virtual network 2 wants to reach out to virtual network 1, it might take the internet path and not go through the peering. I did receive a lot of questions this week around how VNet peering would work with VNet to VNet connections. The fact that you have created a VNet peering between two virtual networks is not a blocker for you to create VNet to VNet connections. So basically, you can still create a gateway in your virtual network, and you can still create either a hybrid connection, so it can be an express route gateway or it can be a VPN gateway, and at the same time, you can choose to take that virtual network, and you can choose to also peer it with another virtual network. So we do insist a lot on virtual network peering, not using gateways, and I think this is why some customers thought that it means that both are not compatible. In terms of the implementation, when you have a VNet peering between two virtual networks, and then you have a gateway and then other connections through that gateway, the traffic between the two virtual networks will always go through the VNet peering. And you can, for example, choose to use the hub mode, where you have decided to have just a hub VNet, and then connect that one to express route, and then take the traffic that comes through express route in the hub VNet, and then peer it with other VNets and make it act as a central VNet. So there are a lot of flavors to this, and there are a lot of ways of deploying it. If you have any questions or anything you would like us to discuss, just email us, email anybody from the team, or contact your account teams, and they will reach out to us and we can discuss those features. So this is it. I did leave some time on purpose for Q&A because we have been receiving a lot of emails around this. So Federico and Victor, if you are both connected, can I ask you to unmute yourselves and tell me if there have been any questions that we need to also discuss here online?
I think there is only one question from Mike, but I don't understand it. So if Mike can unmute and explain what you mean with your scenario, probably we can help you.
Sure, Victor, I'll try. So I was just picking up on the last bit that Sally showed, where you can set up a peering connection so that on VNet 1 side, it includes VNet 2's address space in the local network. But on VNet 2 side, it does not include VNet 1's address space. I'm just asking, if you do that, so you're making the traffic kind of unidirectional, then will responses, like a TCP session, will the return traffic actually make it back to VNet 1 from VNet 2 without an explicit route? Can you hear me, and did that make sense?
Yeah, no, I thought I understood what you said, and we could hear you perfectly. And yeah, so I will be honest, I have never tried that scenario before. So
okay.
What my understanding is, if there is no routes to the other VNet, obviously then the traffic doesn't know how to return to the originating VNet. But again, I haven't tried, so I prefer not to give you an answer rather than giving you a wrong answer. Or this is something we can test and follow up offline. Unless Federico and Sally have already some feedback on this.
Mm-hmm. So the question is around whether we choose to do this unidirectionally, how would the traffic return, correct? Or is it, yes, how would VNet 2 also initiate traffic to VNet 1?
No, just the return
how it
traffic.
Would return.
Yeah.
Okay. My answer would be it would take. I think Federico is.
This is Federico speaking. Actually, this configuration does not affect the VNet route tables. It only affects what's included in the virtual network tag. So basically, it affects only the network security groups that you have in place in your virtual networks. Routing will not be affected, and it will be bidirectional in any case.
Ah, okay, cool. Thanks, Federico.
Thanks.
Great, thanks for stepping in. I didn't read the questions through the IM window. Are there any other questions we need to take? Okay, I'm looking and it seems like, Victor, you have answered most of them. Yes, Takashi, I see a question for the limitations. The default limitation is 10. If you wanted to increase that default limitation, you can do so, but you would have to contact the support, so create a support ticket and ask them to increase it to go up until 50, which is really the hard limit. But yeah, by default, if you don't do anything and in standard mode, you are limited to 10. And Michael, to your point, yes, when you do look at the pricing, there is the traffic that leaves a virtual network and the traffic that enters the virtual network. So yes, I get the point. This would happen on both virtual networks. But again, if you look at the prices are really, really low compared to what you would pay if you had created, let's say, a high performance gateway. But also, again, here you're not limited in terms of throughput. It really depends on the virtual machine you have. So in that sense, I do understand the part that it could be confusing in terms of pricing, but it's really important to take all of the other elements of the pricing if you had the other scenario where you would have a gateway. Okay, looking at the other questions. Okay, so we have a question from Henry. So where do you set allow forwarded traffic on your example? Basically, you would go to the Azure portal, you would look for your virtual network, you would look for the peering possibility. It's really in the same table as all the other elements, diagnostics and all the other possibilities. And then when you create at peering, that is an option that you have. So by default, it's not ticked. If you wanted, you would just tick a box. And you would do this for the VNet that is supposed to do the transition. So the VNet that would take the traffic not coming from it and not distant to it. So that's the VNet you would have to choose this option for. Okay, we have a question from Abdurrahman. Would you like to unmute yourself and share your question?
Okay, hi Sally.
Hi.
So I have a customer that wants to set up site-to-site VPN along with the express route circuit.
Mm-hmm.
So they need to use the basic SKU of the VPN gateway because they use a static VPN device on premise.
Mm-hmm.
So in the supportability matrix, we cannot do coexistence with the basic SKU. And I want to know if there is a plan to support that, and if there is an alternative to have both site-to-site and express route on the same VNet.
With the basic SKU on the gateway, yeah. I did receive this question from another customer. To be honest, I think the direction we're taking is making more performant gateways. So I think that at some point they will try to make maybe work on the supportability of the other SKUs with other VPN devices. I'm not aware of plans of them that they're working on right now to allow this feature to work. So basic SKU gateway to work and coexist with the express route gateway. But maybe we can ask engineering and take this offline and ask them if they do recommend a workaround.
Okay, thank you.
I'll follow up on this with you offline.
Okay, thank you.
Oh, Henry, you would, in which VNet do you set that on? You would set that on the VNet that would have to take the traffic. So in my scenario, I don't know if maybe I can move back the slides. Let me show you. Okay, it's here. You would activate this in this specific scenario for VNet 2. So this is where you get the allow forwarded traffic here. And you would do this for VNet 2. So remember, VNet 2 is the VNet that is paired both with VNet 3 and with VNet 1. Right? So this is the VNet that will take traffic from VNet 1 to VNet 3. The traffic doesn't come from it. It's not destined to it, but it still does that job of transit routing. That is the VNet where you would have to allow forwarded traffic. So VNet 2, to answer your question. Okay, great. Do we have any other questions, any other comments, any other feedbacks? We should also report back to engineering. So I take the feedback from Abdul Rahman. Do we have any other things you wanted to share? Okay, great. Well, in that case, I thank you for joining this call. I wish you happy holidays. And I hope we will see you again in our calls starting January, where we will cover hybrid connectivity, express route, and many other subjects. So stay tuned and just email me if you would like to get the invites or if you would like me to invite your customers to the next sessions. And thank you so much for joining. Thank you, Victor. Thank you, Federico. Thank you, Richard.